Hey everyone, here are the notes for lateral and surface area. So, we have prisms, cylinders, spheres, pyramids, and cones. To start out with our prism, we're going to break it down into the lateral area and the surface area. First, we need to understand that surface area is the area of every single surface for our figure. So in this example, this is a prism. This is a triangular prism specifically because the base of this is a square. If we look over to the right, this is a rectangular prism because the base is a rectangle. Still, the surface area is the area of every single surface combined. Lateral means sides, and so the lateral area is the area of just the 3 sides here or just the 4 sides here, all combined. We have 2 formulas, one for each of them. For the lateral area, we take the height by the perimeter. So here H stands for height, and specifically this is the height between the bases. Height between the bases. And so if in pink I were to highlight the base, this here would be the base. This would also be a base, the one on top. The height would be the distance between the 2 bases, as indicated here with this H. P stands for perimeter. This is the perimeter of the base. So the perimeter of a base, meaning if I were to take the 3 sides of this triangle, add them up, that's the length around the triangle, or here, take the 4 sides and add them up. So let's calculate the lateral area first before we do the formula for surface area. The lateral area here, we have a rectangular prism. Let's choose this as our base. And our height would be the distance between those 2 bases. So this base versus this base. For lateral area, your lateral area will be different depending on which base you choose. And depending on which base you choose, then your height would be different. So I'm going to intuitively think that this one's my base because it's on the bottom. It's not always going to be that way, but for this problem, I'm going to choose this as my base, so 10 would be my height. So I would plug in 10 for H, and perimeter would be 5 plus 4 plus 5 plus 4. That gets me 18. So I multiply these values and I get 180, and my units are squared for anything to do with area, so inches squared. So if the lateral area is the area of all of the sides put together, the surface area would be the sides and the bases. So I take my HP from my lateral area, and I'm going to add 2 times capital B, where this capital B is going to indicate the area of a base. So whatever shape we have will be different. So here our B would be 1/2 base times height for a 2-dimensional triangle. 1/2 little b times H. For this one, our capital B would be the area of a rectangle, which would be base times height. So here, for surface area, I have HP plus 2B. And I'm going to calculate in another color off to the side what my capital B is going to be for my specific shape. I indicate here that this is a rectangle. So I can identify that base times height, if I think about 2-dimensional, the base times height. Remember, base and height, no matter what, need to be perpendicular. 5 and 4 would be my base and my height. So the area of my base would be 20. This B is going to get plugged in here. H we knew was 10 from above, P was 18, and now I'm going to add 2 times 20. So I got the 180 from earlier for my lateral area, and now I'm going to add 40. So my overall surface area will be 220 inches squared. Moving on to the next problem here, my base is now not a rectangle, but it's a triangle. The height between the 2 bases is my 6 right here. So to calculate the lateral area first, still just H times P. The height between the bases is 6. The perimeter, so 5 plus 9, and this distance here, this is 12. It's the same as this one. 5 plus 9 plus 12 is 26. And then 6 times 26 is 156. So the lateral area is 156 units, which are meters squared. For the surface area, we take our h times p plus the area of two bases. Again, off to the side, I'm going to calculate that two-dimensional area of the base, which is a triangle, and my formula for that is 1/2 base times height. So this is an example as to why we use a capital B as a placeholder for the area of whatever base we have, because sometimes it's a rectangle, or it would make it a cube, or a triangular base. So what we do still is plug in our base and our height, remembering that base and height must be perpendicular. So we notice here that 12 and 3.4 have that perpendicular box. So those are the base and height, the perpendicular values. So 12 and 3.4. 12 times 3.4 times 1/2 is 20.4. So we get that the capital B, the area of my base, is 20.4. Plugging that back in, h, we saw from earlier, was 6, perimeter was 26, plus 2, takes 2 times 20.4. We end up getting 156 plus 40.8. So the overall surface area is 196.8 meters squared. Similarly for a cylinder, we will take the height and multiply it by the perimeter of the base. But in the case of a cylinder, the bases are circles, and another way to say perimeter of a circle is the circumference. And we have a formula for the circumference of a circle. That's 2 pi r. So I'm going to take that. That is technically the perimeter of the base, and I'm going to multiply that by the height. So let's calculate the lateral area of our example here. So let's see that this is the base. The 32 here is our height. So lateral area is 2 pi rh. Well, our problem, we're given the diameter, so let's identify the radius. So if the diameter is 15, half of that, 7.5, is our radius. So plugging that in, we get 2 times pi times 7.5 times 32, plugging in all of our pieces. Let's leave our answer in terms of pi for right now. So 7.5 times 32 times 2, we find that the lateral area is 480. We didn't multiply pi, so let's add that there next to it. And then we've got centimeters squared for our units. Just like with the prism, where we had the lateral area, then we added the area of the two bases, we're going to do the same thing for the cylinder. So 2 pi rh from the lateral area, plus 2 areas from each base. So we've got our one area from each base. So we add the area here, and we add the area here. Well, the bases are circles. So again, we know the formula for the area of a circle is pi r squared. So if I add 2 pi r squared, that takes into account the area of both bases. So moving over here, let's calculate 2 pi rh from the lateral area, plus 2 pi r squared from the area of the bases, and plug in all of our individual pieces. 2 times pi times 7.5 times 32, plus 2 times pi times 7.5 squared. From above, or from next to this at this point, we had 480 pi from this portion right here. Add 2 times squared, that's 112.5 pi. These two pieces combine for the overall surface area of 592.5 pi centimeters squared. For a sphere now, moving on to our sphere, we don't have any lateral pieces, no sides here. We don't even have any bases. We just have one overall surface. So there's only a formula to find the surface area, and that formula is 4 pi r squared. Again, in our example here, we're given the diameter. So let's find that the radius, if the diameter is 22, the radius is 11. And we'll use that value to plug into our surface area formula of 4 pi r squared. So 4 times pi times 11 squared. Plugging all of that in, 4 times 11 squared, leaving the pi out of it, we get 484 pi, and our units are yards squared. To find the surface area of the Earth, we're assuming that it's a perfect sphere and it has a radius of 6,369 kilometers. So we're going to plug that value in for our r. So SA, surface area, equals 4 times pi times 6,369 squared. We find that our overall surface area of the Earth is 162,256,644 pi kilometers squared. Quite large. All right, moving on to the next page, our pyramid and our cone. Pyramids and cones now have a new piece. And that new piece, as we can kind of see in this picture here, right here, that's an L, and that's talking about this dotted line here along the edge or the side of the pyramid. That's called the lateral height. I also call it the slant height because it's slanted. So our formula for the lateral area of a pyramid is going to be 1/2 LP, where again L means lateral height, and I'm going to call it, its nickname that I give it here, the slant height, because it's slanted. The 1/2 comes from it being half. The side here of a pyramid is half the side of if it were a cube. That's where the 1/2 comes from. And let's go right into the surface area. It's again the lateral area plus the area of the base. And one base here we have is just capital B. We leave a capital B because sometimes we would have a triangular base or a polygon base, something else. So looking at our first example here, our base, we have a square, 4 by 4. And the slant height is the height along the side here, the lateral height of 7.3. So I'm going to plug that into my lateral area formula, 1/2 LP. 1/2 L, which is 7.3, times the perimeter. 4 plus 4 plus 4 plus 4 is 16. Plugging all of those in, we get 58.4 feet squared for the lateral area. All right, next up we've got our surface area, 1/2 L capital B. Again, we have a capital B, so off to the side I'm going to think about my two-dimensional area. Base times height, 4 for our example here. So the area of the base is 16, and that B will get plugged in right here. I knew that from 1/2 LP from earlier. We already found that that was 58.4. So to save on some space, I'm just going to copy that number over. And then I'm going to add 16 to it from the area of the base that we calculated. So overall, the surface area is 74.4 feet squared. Alrighty, same idea for this pentagonal base. Let's find the lateral area first. 1/2 LP, where the lateral height, or the slant height here, that's that 13.5, the height along the side of the pyramid. The base is this pentagon, and it's a regular pentagon, kind of indicated they're a little bit faded, but the tick marks that we have here and the markings inside the angles to indicate that all of the angles are congruent, that tells me that that pentagon is a regular pentagon. And we'll need to know that for when we're calculating the area of that base. But let's do the lateral area first. 1/2 times the slant height, which is 13.5, times the perimeter. 9 plus 9 plus 9 plus 9 plus 9, as each side is 9. Perimeter is 45. So we actually did need to know that it was a regular polygon to get the sides of the perimeter. They all have to be the same because we don't have numbers on each one. So that's how we found the perimeter. Multiply those numbers, we get that the lateral area is 303.75 meters squared. For our surface area, we have 1/2, we already found, plus the area of the base. So over here, my two-dimensional base, my polygon, is going to be 1/2 apothem times perimeter. That's the formula for the area of a polygon, where the apothem is the distance between the center of the polygon perpendicular to one of the sides, and we have a 6.2 there. So we don't have to use trig or special right triangles or anything to find the apothem. It's already given to us. So we're going to plug that value in. 1/2, 6.2 times the perimeter, which we already found for earlier, was 45. So we find that the area of our base, let's do 1/2 times 6.2 times 45, we get 139.5 for the area of our base. And that value is going to get So the 1/2 LP, the lateral area that we already found, I'm going to copy that over, 303.75. To that, I'm going to add the 139.5. So our overall surface area should be 443.25 meters squared. All right, one more figure. We have the cone up next. So cone is going to be similar to our lateral area formula. So it's going to be 1/2 of the, with the slant height. So instead of 2 pi RH as it relates to a cylinder, half of 2 pi RH is just pi RH. And instead of multiplying by h, we're going to multiply by the slant height. So pi RL is the lateral area formula for our cone. Pi RL plus the area of one base, so just plus 1 pi r squared is the entire surface area formula. So our base here is the circle, and our slant height is the 8.9. Plugging that into our lateral area first, pi RL, pi times the radius times the slant height, and that's an 8.9. I know it looks like a 6.9. We get that the lateral area is 35.6 pi inches squared. Surface area, continue on. Pi RL plus pi r squared, again we are, brings us, that's 35.6 pi, plus pi times 4 squared. So we have the 35.6 pi plus a 16 pi, which together bring us 51.6 pi inches squared. This one is similar. We have everything that we need except we're given the diameter, so we want to think about what the radius is instead. The radius would be 11. So we're going to plug our pieces in. Lateral area is pi RL. But before we do that, I want to think about what would happen if instead of being given the slant height, we were given the perpendicular height. If we were given the 11 and the perpendicular height instead, what would we do to find the slant height? And the answer to that is the Pythagorean theorem. So we don't have to do that for this one, but if instead of being given the slanted height, you were given the perpendicular height, that is what you would do, the Pythagorean theorem, because technically this would be a right triangle with a leg, and you'd be missing the hypotenuse. So hypothetically, if that's what you were missing, that's how you would find the lateral or the slant height. So let's plug in the pieces that we do have. We have pi times the radius times the slant height, which is 24.6. So our lateral area is 270.6 pi centimeters squared. And then our surface area, we take the lateral area plus the area of the base. So we already found the 270.6 pi. Now we're adding pi times r squared, the area of the circular base. So we get 270.6 pi plus 121 pi. Together we get the overall surface area of 391.6 pi centimeters squared. Alrighty, so at the bottom of the page, we're just going to fill in quickly down here